Hello all, welcome back to the part B of lecture 9. In this video lecture, we will do some hands-on with R. So let me first open my R Studio. So this is the code that I have partially showed you in the in my first part of this lecture 9, where I'm going to use this first line, the live T-series package. In case you don't have T-series package in your so if you run this, so in this case you may get a it is this kind of information. If you don't have T-series package, then in your R installed, then what you can do, you can see here there is a package, you can see. Okay, in package you can click on that, you can go to install, and then if you write T-series and make sure your install dependency is corrected, checked, and then you click install. Now I am not going to install because it is already installed in my R environment, so I'm cancelling it. Now I'm going to consider the start date as 1st June 2022, and in the analysis that I have shown in the package in the previous video, I have considered 30th December 2022. However, what we can do, we can, instead of that, we can take the end date as usual, some end date of sys dot date. If you just take sys dot date, so that will give you the today's date. Today is 7th February 2023. As of I am recording this video, it is 7th February 2023. And what I can do is I can take a start date which is maybe 60 days prior to the system date. So what I can do, I can just take sys date minus 180 days, like 6, or maybe I just take last 90 days of data. So if I just give this, then start date will be 90 days prior, which is 9th November 2022. Now given these two dates, so now get.his.code is the function that comes with the package T-series. So if you just question mark get.his.code, then you can download historical financial data. Okay, and here there are some examples also. So what you can do, I am going to download the instrument name reliance.ns. you can try some other stock also, like TCS or something, but you have to know with the name of the instrument, in this case TCS. So one way to figure out which instrument you want to use is you go to Google, Yahoo, you search Yahoo Finance India, make sure you're giving Yahoo Finance India, and then if you click on that, and then you can look for typically quote lookup here. If you just give, say, TCS, if you give TCS, okay, so TCS.ns is the Tata Consultancy Services. So Tata Consultancy Services, that is TCS.ns. So if I want to download the data for Tata Consultancy Services, so I will choose TCS.ns and I'll go in my R, and here instead of reliance.is, I will say TCS.ns, but I'll just keep it as reliance.ns, and I'll just download the data. Oh, I need to just run this too, and I'll just run the data. Now if you go to the environment, so you can see the Reliance, it has downloaded a zoo package. Similarly, you have, if you just say head Reliance, this is the object name. If you just say Reliance, so it has the adjusted close prices of Reliance. Now if you say tail of real, so till yesterday the price was 2311.45 per share. Okay, now Nifty is the index. If you go back, if you remember, so this is the Nifty 50. Nifty 50 is the index of National Stock Exchange. This is the 50 largest company of the country. So if you just run the Nifty 50, it will give you the Nifty values also. Similarly, you can see you can say head of Nifty, and similarly you can just say tail of Nifty. You can see that in November it was running around 18,000. Now it is came down to 17,000. The market is not good now as of February. So now what I'm going to do, I'm going to run the merge these two, and it will automatically merge. And so head data, so now it's a adjusted Nifty and adjusted Reliance. So two series got merged by date automatically, so you don't have to worry about that. And now if you just calculate this, now head of RT times 100, this is precisely the value that you have seen, that this is the Nifty log returns and these are the Reliance log return. Okay, now I have taken risk free rate as 6%. I'm going to, so that's why I've taken rate as 0.06. okay, and I'm going to divide that by 252, because there are 252 business days. You can use 365 also. We can use 365. That will be probably more meaningful. So we can use 365. So the risk premium, if we just calculate, just subtract risk free from the return. So now it is risk premium. Now RT, because I have just subtracted the risk free rate from all the returns, and that obviously then the rate RT data frame is, now what I have is risk free rate, risk premium. So these are all my risk premium now. So if I now plot risk premium, the adjusted, so these are my, let me just zoom it. So these are the Nifty return on the x-axis and Reliance return on the y-axis. Okay, looks like there is a, or Nifty premium, I should not say return, Nifty premium, risk premium, and Reliance risk premium. So that is the more correct, appropriate value. So let me just run it once more. Now it is corrected. So yeah, Nifty risk premium and Reliance risk premium. So now if I just run, put some grid on it, P line, so you can see around 0 I put a line, and so most of them are like, you know, almost like a 45-degree line it is getting created. And then what it does, that it fit the Reliance industry as a function of Nifty, and then it just Yeah, so it just create this line through the almost through the center. So now if I fit CAPM, just all you have to do, Reliance, the risk premium of Reliance as the response and risk premium of Nifty market index as the predictor, call LM and provide the data RT. RT contains all the risk premium after subtracting the risk-free rate from the log return. So now you run the CAPM and run the summary. So this is the alpha and this is the beta. So beta is 1.12 and alpha is negative 0.00153, but p-value is 0.151, so we cannot really reject the null hypothesis that alpha is non-zero. So we can say that Reliance prices are fairly priced. Okay. First, we would like to do some quick linearity check. So first we will take the residuals, take the y hat and do some plot of residual versus y hat. So here is the residual and here is the y hat. You can do one more thing also. So now here you have fitted plot. If you just fit plot CAPM, if you just fit plot CAPM, you will see a bunch of plot will get created. This is a built-in function in R. So this is the first plot that you will get. So here you have fitted value versus residual. Okay, fitted value versus residual, and some of the points are like sort of an outlier, but and then second plot it will be QQ plot. It says that looks like some of the points are, it's bit away from the QQ line. Normality is looks like questionable. Then third is fitted values versus standardized residual, and there are some huge outlier as usual we were seeing, and this is the leverage versus standardized residuals. I have not discussed what is leverage and Cook's distance, all those things. Going forward, I will teach you what is leverage, what is Cook's distance, all those issues. So at this moment, I will not be able to explain this particular plot, but I am hoping by in next 2 weeks, I will be able to teach you what is leverage and what is residuals, and at that time I will be able to explain this plot to you. So our usual things I will check. So here we have done a quick thing. As of then we have test for randomness test, and what we found that p-value is bit high, so randomness is okay. So the assumption of randomness is okay. Then we can run the Bruch-Pagan test for homoscedasticity. So let us run the Bruch-Pagan test for homoscedasticity, and p-value, you can see p-value for Bruch-Pagan test is also very large. So the assumption for homoscedasticity is also okay. Now you run check for normality. So looks like these points are far away from the QQ line, so there is a questionable thing. Is the assumption of normality okay? So let's run the Kolmogorov-Smirnov test, and clearly p-value is very small, very small. Like after 0.14 zeros, and then after 14 decimal place you are getting 2054. So it is impossible. So assumption of normality is not correct. Therefore, this inference that we did, this inference is now not anymore valid, because this test is done based on t value. and t-value requires the assumption of normality, and clearly our residual does not follow normality. So this assumption, this entire analysis is not valid anymore. Okay, so in order to solve this situation, what typically we do, one possible solution is bootstrap regression and non-parametric bootstrap regression. So at this moment I am going to stop here, and in the next video I will start discussing what is bootstrap regression, and then I will do the hands-on how we can solve this problem of capital asset pricing model using bootstrap regression. I hope you enjoyed this video. Thank you very much. See you in the next video.